All right, continuing on here, we'll go on to the next question. So we're going to use this formula again, the gravity formula, negative 16t squared plus v sub 0 times t plus h sub 0. You can see part 1 of the video for the introduction on that. So for this one, it says it's dropped from an initial height of 100 feet. So obviously the initial height is 100. And then if it's dropped, that actually means that the initial velocity is 0. Just so it's not being, there's no force being exerted upwards or downwards. And so I would write this one as h equals negative 16t squared. And then since v sub 0 is 0, this whole term is just kind of gone. And then I'll just add the h sub 0 at the end. Okay, so then this one asks when, oh, the h sub 0 is 100, sorry, not 50. Initial height. Okay, when will the object be 50 feet above the ground? So for that one, we're going to take this equation and we're going to plug in a 50 in for height. Usually that h out front is the h they're asking about. Now this is a quadratic, but we don't have that b value in the middle, and so we don't have to use a factoring or quadratic formula here. We can go ahead and just solve with square roots. So I'm going to go ahead and subtract 100 from both sides. I don't really have space to show that, so if I subtract 100, then that's going to be negative 16t squared on the right-hand side, and then because the 100 will cancel out, and then it'll be negative 50 on the left-hand side. Then I would divide by negative 16. We can go ahead and reduce that fraction to, what would that be, like 25 over 8. And I would make it positive now since it was negative over negative. Then I can take the square root. And since this is a word problem, I'd probably just type this into the calculator. So the square root of 25 divided by 8. Let me pull up my calculator here. Alright, square root of 25 over 8. Alright, so technically if I do a square root, if I create a square root, I should say plus or minus, and it's about 1.77 seconds. Now, I think the negative answer here doesn't really make sense to have negative time, and so we would just say the positive version of the answer for the word problem is 1.77 seconds. Okay, next up says, when will it have a height of 120 feet? So I'm going to go ahead and just use that same equation from part A, but I'm going to plug in 120 in for the height. Kind of solve it the same way. So I'll subtract the 100 over, so it says 20 equals negative 16t squared. Then I'm going to divide by 16, or negative 16, so t squared equals negative 20 over 16. I could reduce that if I want, but I notice when I take a square root here, I have a negative inside the radical, which means it's an imaginary answer. And so for the purposes of this word problem, that's actually trying to tell us that it never gets to a height of 120 feet. It actually makes sense if you think about it, because if you drop it from 100 feet, it's not going to go up to 120 feet. If you throw it up, it might get there, but if you drop it, it's definitely not going to get there. So I just like to see that the math actually matches up with like the logical answer, which is it's never going to happen. So if you get an imaginary answer on these real world type of problems, it's kind of trying to tell you that something's not possible there. Okay, then last piece here, when does it hit the ground? So for this one, we're going to take that same equation, but now we're going to put 0 in for height. I don't think we're going to get an imaginary answer for this because it should hit the ground, right, if we drop it. So I'll go ahead and subtract the 100 over again. I'll divide by negative 16. Let's see, we can actually reduce that to 25 over 4, right? Yep. So then we'll square root it. T equals plus or minus 5 over 2. Now, again, the negative answer doesn't really make sense here, so I would say 5 over 2 seconds. We could do the decimal for that as well. It would be like 2.5. Either way is fine. Okay, so one more problem here we can set up. So ball is, all right, so we had our initial velocity. It's thrown up, so it's going to be positive. So I'll say negative 16t squared plus 24t. And then the initial height is 200. Okay, and then they ask after it's thrown up, when does it get back to a height of 200 feet again? So I'll put 200 over here. Now this is a quadratic, so we want to get one side to 0. I actually notice here that the 200s can cancel out. If I subtract 200 from each side, it would say 0 equals negative 16t squared plus 24t. So it is still a quadratic, but I can just use GCF factoring now since the c canceled out there. So I'm going to take out a negative 8t, which is going to leave me with 2t minus 3. And remember, when you take out a negative, it switches the signs. All right, so now I can set these each equal to 0 and solve. Okay, so for this one, I would divide by negative 8, and that means t equals 0. Remember, anytime you have that GCF variable out front, no matter what's attached to, it's going to be 0. This one would say 2t equals 3, so t equals 3 over 2. Now, which one answers the word problem? Well, it says, when does it reach a height of 200 feet again? So this t equals 0 is saying it started off at 200 feet, which we kind of already knew. And so I would say 3 over 2 seconds here. And that is a positive. I know it's hard for me to write super neat here, but positive 3 over 2 seconds, so like 1.5 seconds. All right, next one here, when does it reach the ground? So for this one, we're going to take that original equation, and we're going to set it equal to 0. Okay, and then we can factor here. What can we divide by? Can we divide by 8? Yeah, definitely 8. I'm actually going to do negative 8. So if we do negative 8, it's going to be 2t squared minus 3t minus 25. All right, now we can try to factor it. So a times c here would be negative 50, and then b would be negative 3. Okay, so do we have two numbers that multiply to 50 and add to 3? I don't think so. That's not going to work. Let's check. 1 and 50, 2 and 25, 5 and 10. I think that's it. So none of those are going to make 3, so we do have to use quadratic formula here. All right, so we're going to do x equals, and again, I would use it on the factored version with the smaller numbers. So negative b would be positive 3 plus or minus the square root. B squared is 9 minus 4 times 2 times negative 25. And that's all over 2 times 2. Okay, we'll simplify a little bit in the radical there. So that would be x equals 3 plus or minus the square root of, let's see, that would be 209 divided by 4. Now, on like a normal math problem, I try to break down that radical 209, but on a word problem like this, we usually just want a decimal answer. And so I would just type this into a calculator and get 2 decimal answers. You do the plus or minus by just doing 1 plus, do it once as a plus and then once as a minus. Now, one thing is that when we do this on most calculators, you need extra parentheses around the numerator. Anytime you have adding or subtracting inside of a numerator or denominator, when you type it in the calculator, you need some extra parentheses there. So let me start typing here. So 3 plus the square root of 209 divided by 4. And so I get one answer here is 4.36 seconds. And then I'll do it again with a minus. And I get negative 2.86 seconds. So the negative answer, I would say, doesn't really make sense. So we'll take that positive 4.36. All right, next up, we're trying to isolate a different variable here. So whatever it tells you to solve for, that's what we want to isolate. So for this one here, I would put this as g over 1. I would kind of see it like that. And then I would multiply this fraction. So I would really see it as g big M little m over r squared, kind of just top times top up top, bottom times bottom on bottom. Now we're trying to solve for r here. So I'm trying to get r by itself. Right now it's in the denominator, which is not good for us. So we should multiply both sides by r squared. So it's not in the denominator anymore. So r squared times f equals g, big M, little m. Then I would divide the f over, cross that out. Okay. And then my last step here, because r is not quite isolated yet, is that I would square root both sides. Now, since I created that square root, I would say my answer here would be plus or minus the square root of g, big M, little m, over big F. Okay, number 2, we want to isolate w here, and this is kind of a tricky one because we have two w's in these two terms, and they're unlike terms. We cannot combine them. I cannot have w as like part of my answer. So here's how we do these. Anytime you have two variables in unlike terms, get all of the terms with that variable on one side, all of them without on the other side. So I'm going to keep the w's on the right-hand side. I'm going to move this 2lh over here. And so it'll be a minus 2lh equals 2lw plus 2wh. And now what I'm going to do is, now that I got those on the same side, I'm going to factor out a w. And I get 2l plus 2h on the inside there. And so now that I have that w factored out, you can see now I only have one w. So I can just divide by this parentheses here, 2l plus 2h. And that cancels out over here, so I have isolated w, and there's my answer. All right, next up we got solving rational expressions. So I like to make sure that if we have adding fractions on the same side, you just add them together with common denominator, and then you cross multiply. Which is not to be confused with cross-canceling. So I put a little diagram there. So if the fractions are multiplying, we can cross-cancel. If the fractions are equal, we cross-multiply. So this times this equals that times that. If the denominators have anything in common, we can cancel them out. And then we do have to check for extraneous solutions at the end. Really just make sure that it doesn't make any of the denominators 0 from the original equation. Okay, so for this one, we're going to multiply this side by x plus 2. And we're going to multiply this one by x to get that common denominator. So we got that common denominator is x times x plus 2. My numerator here, I do need to distribute that 3. So it's going to be 3x plus 6 plus 5x. And so that's going to simplify to 8x plus 6 over x times x plus 2. And now I'm going to bring down this other side of the fraction, or of the equation, which I want to write as a fraction. So I'm going to write it as 2 over 1. And then I'm going to go ahead and cross multiply. So this times this, obviously 1 times anything is just itself. And then the other way would be this times this, which I'm going to write as 2x times x plus 2. Now to solve this, I think we need to distribute into here. So we get 2x squared plus 4x equals 8x plus 6. I see this is a quadratic, so I need to get one side to 0 and factor. So we're going to minus 8x minus 6. Get 0 equals 2x squared minus 4x minus 6. Try to factor this. I see we do have a GCF here of 2. Take that out. Divide everything by 2 inside. And now I can do a little x factoring here, thinking of two numbers that multiply to negative 3 and add to negative 2. So that would be negative 3 and positive 1. I can use the shortcut here because we have nothing in front of the x squared. We took that 2 out front. That makes it a lot easier. Now remember, when we take that 2 out front, we do not set that equal to 0 because no variable. And then x minus 3 equals 0 means that x equals 3 if I add it over. You can always also kind of just switch the signs on these. All right, now I need to double check. Do either of those answers make the original denominator 0? No. If I was looking at the domain on this original question, I would say x cannot equal 0 and x cannot equal negative 2 because that's what makes these denominators 0. So since neither of those are my answers, that means these answers are good. All right, so next up here, same idea. So we need to add these together with common denominator. Now these ones the denominators look different, but if I factor here, thinking of two numbers and multiply to 30 and add to negative 11, I would do negative 6 and negative 5. So really this is a v minus 6, v minus 5. It also kind of tells me my domain for this question. I know that v cannot equal 5 and v cannot equal 6 because that would make these denominators 0. So if I get either of those answers, then I have to cross them off as extraneous. Okay, so I do need to multiply this middle fraction by v minus 5. Let me do that in a different color because it is kind of the next step here. So since that's missing the v minus 5, I'll go ahead and multiply by v minus 5 on top and bottom. And then we're going to put these together in one fraction, v minus 6, v minus 5, our common denominator. In the numerator here, I need to actually FOIL these two together. So it's first times first is 5v squared. Okay, outer times outer is negative 25v. Inner times inner is negative 3v. So combined, that makes negative 28v. And then last times last is positive 15. So I just FOILed those together. You can also use the multiplying box. Now this other one, I didn't change, so I can just rewrite that. You'll notice you could have factored that, but we don't want to because we need to combine these like terms. Okay, so when I do that, I get, let's see, 5v squared and 6v squared. I'll do this 5v squared and 1v squared makes 6v squared. So I get 6v squared. Negative 28v plus v is negative 27v. And then what do we got? 15 minus 2 is 13 over that common denominator. And that equals that 2v over v minus 6, v minus 5. Okay, now I did say in the instructions that if you have anything in common in the denominators, once you get it into this step, you can cross them off. And you can see these ones are actually the same denominator, so I can cross everything off. We're only allowed to do that denominator to denominator when they're equal. Of course, if they're multiplying, we cancel top to bottom, but equal, we can cancel bottom to bottom. The reason why is we were thinking like that we can like multiply both sides by v minus 6, which would just cancel it down. We're allowed to do that on both sides of an equation, and then multiply both sides by v minus 5 and cancel down. Okay, so I see actually now I don't need to cross multiply because all my denominators are gone. I do have a quadratic here, so I want to get one side to 0, so I'm going to subtract the 2v, and we'll move that up there. So I'm going to say 0 equals 6v squared minus 29v, now that I subtracted that 2v over. All right, and now we need to factor that. So we're going to think of two numbers that multiply to, what's 6 times 13? 6 times 13, I'll use the calculator to make sure I get it right. That's 78 for my a times c, and negative 29 here. So what multiplies to make 78? Let's see, 78, is it divisible by 4? No. 3? Yes, 3 and 26, so I go negative 3, negative 26. Okay, now this one does have the 6v out front, so I cannot use the shortcut here. It's not going to be v minus 3, v minus 26. I have to rewrite this first term, 6v squared, split up this middle term, negative 3v, negative 26v. I'm getting those numbers from the x factoring, and then put the 13 out there. Now I'm going to use the grouping technique. So I group these two together, group those two together. I can take out a 3v here, leaving me with a 2v minus 1. I can take out a negative 13 here, leaving me with a 2v minus 1. So I get 3v minus 13 for the stuff on the outside, and 2v minus 1 for the stuff on the inside, and that's equal to 0. So now I can split those up and set them equal to 0 individually. So 3v minus 13 equals 0, 2v minus 1 equals 0. Now I'm almost out of space here, so I'm just going to kind of do this in my head. So for this one, if I'm solving for v, I would add the 13 and then divide by 3. So that's going to make 13 divided by 3. Over here I would add the 1 and divide by 2, so 1 over 2.